Hello students, in this video we are going to continue with chapter 2 on separation techniques, and we know that separation techniques are methods used to separate mixtures, okay? And the mixtures are made up of more than one pure substance, and we have two types of mixtures. We have heterogeneous mixtures and homogeneous mixtures. Okay, so heterogeneous mixtures are made up of two or more phases. That is, for example, like oil plus water. That's an example. That is a heterogeneous mixture. And homogeneous mixtures, they are made up of one phase only. Like, for example, salty water. So salty water is a mixture, but we can only see one phase, the liquid phase. We can only see the water, but we can't really see the salt, but it's actually a mixture, okay? And in this chapter, we were talking about how to separate mixtures. First, we talked about the way to separate heterogeneous mixtures. We spoke about decantation, which is the way to separate mixtures based on the difference in their densities. We talked about centrifusion, which is a speed up of decantation. And we talked about filtration, where we used a filter paper and the mixture would pass through the filter paper and the residue will stay up on the filter paper and the filtrate will fall into the beaker. Okay, in this video we're going to focus on a method to separate homogeneous mixtures, because we really can't use these types of separation techniques to separate homogeneous mixtures. We have other types or other ways or other methods of separation to separate homogeneous mixtures. The first method is the simple distillation. So we are going to focus on simple distillation. So simple distillation, in simple words, is a technique. It's a technique that uses the difference between the boiling points. It uses the difference between the boiling points. Please remember this part. Of the components of a mixture to separate them with the aid of a specific setup. So I'm going to read it again. So it's a technique that uses the difference between the boiling point. So it uses the difference between the boiling point between the components of the mixture to separate them using the aid of a specific setup. So the first part, we are going to see why the boiling point and the difference in the boiling point actually matters. And then in the second part, we are going to study the specific setup or the distillation setup. So first, how can we benefit from the difference in the boiling point? We are going to try to answer this question. So we know that each pure substance has a specific boiling point. We learned that pure substances have specific boiling points. Let's say water, it's a pure substance. Its boiling point is 100 degrees Celsius, and that's a constant in water, in a pure substance. And other pure substances have specific boiling points as well. And that's a way to specify pure substances. And now, in a mixture, so in a mixture of two and more pure substances, each substance starts to evaporate at a specific temperature. So when we have a mixture of more than one pure substance, each pure substance has its specific boiling point. We learned that. So each of these substances is going to evaporate at a specific temperature. Now, how are we going to benefit from that? So we heat this mixture and we start collecting the vapor of the mixture at specific temperature. So a part of the mixture will evaporate at first, and then another part will evaporate based on the temperature. We're going to learn more about that. So we collect the vapor or the gas and of each substance at a specific time, and then the vapor condenses. What's the meaning of condense? To condense is to change from gas to liquid. So the vapor that we collected in a specific manner is going to condense. It's going to change from gas to liquid. We know that vapor means a gas. So vapor means gas. It's a gas in the gas state, not in the liquid, not in the solid state. It is in the gaseous state. So yeah. So the vapor will condense and it will change from gas to liquid. And how is that going to happen? It's going to happen using something called the condenser. We're going to see that in a minute. And then we collect the liquid. So after the vapor condenses, it becomes liquid and we collect the liquid. Now let us learn more about this apparatus and the mechanism. So we are going to learn exactly how this works. So I'm going to use an example. This example is a mixture of alcohol and water. So we have a mixture of alcohol with water. The mixture of alcohol and water is actually a homogeneous mixture. We know that because we can see only one phase. And the data or the information that we have is that the boiling point of water is 100 degrees Celsius and the boiling point of ethanol or alcohol is 78 degrees Celsius. So we're gonna think together and try to know how will this separation technique work. So we have this beaker, okay, and it is filled, it is filled with water and alcohol. And let's say we start heating this beaker. At first, this beaker would be at room temperature. That is almost like 23 degrees Celsius. And when we heat it, the temperature will start increasing and increasing even more. Now, as the temperature increases, it's going to reach for sure, let's say 78 degrees Celsius at first. So when it reaches 78 degrees Celsius, what happens? Ethanol evaporates, that's true. So ethanol will evaporate, right? And the temperature will start increasing even more. When it reaches 100 degrees Celsius, what will evaporate now? Water is going to evaporate. So water evaporates. At what temperature? At 100 degrees Celsius. And what we do is somehow we're going to collect the vapor of ethanol first and then of water first, and that's how we're going to separate the mixture, okay? So we're gonna just remove this so we have more space, and this is our apparatus. Well, I think it looks a bit complicated, but you have to trust me, it is not that complicated. So inside here we have the mixture of alcohol and water, and here we have the Bunsen burner. It is heating the flask. As we said, the temperature would be first room temperature and then it will start increasing. Remember, the boiling point of ethanol is 78 degrees Celsius, and we start at 20, let's say, or 23 room temperature. With the Bunsen burner, the temperature increases, and it reaches 78 degrees Celsius. Okay, when it reaches 78 degrees Celsius, ethanol will evaporate. Okay, now as it evaporates, it's going up into this tube that's called fractioning tube, and this fractioning tube collects the vapor inside of it. Okay, so this is the Bunsen burner first, this is the tripod, this is a flask, and this is the fractioning tube here. So, and up here we have a thermometer. So the thermometer, it measures the temperature. Okay, so the vapor will come up here into this fractioning tube, and it will go into this small tube into the condenser. What happens in the condenser? Well, there's heat exchange between the vapor, the ethanol vapor or the gas, and the environment. So the temperature of ethanol will decrease, and ethanol will turn from gas to liquid, because remember, when we heat something, it turns to gas. When we cool it down, it condenses. It means that it turns back into liquid. So along this condenser, the gas will turn into liquid, and the liquid will fall from the condenser into a different flask. Now, as I'm going to choose another color, as the temperature increase even more from, so that's not a really good color, this one's better, from 78 to 100 degrees Celsius, it means that that water is going to boil and evaporate. Now water is going to evaporate, and it's going to fill this flask with water vapor. It's going to go through the same track, it's going to turn into liquid, and then it's going to go into the other flask, because we're going to change the flasks. That's basically how we separate homogeneous mixtures using this distillation technique. Okay, now I'm going to show you the image you have in your book. I want you to open the book at page 32, okay, and check the figure 11. We have the setup for the fractional distillation. So the tripod, it's a stand that holds the flask, and we have the Bunsen burner. It's a heater, it has a little flame here, and we have the flask. It's a round bottom flask because it's a round bottom, and the fractioning tube or the fractionating tube, it's where the vapor is collected, and from there the vapor would go into this condenser. Okay, and there's a thermometer up here to measure the temperature so that we know when we change these flasks. So when the temperature reaches 100, we know that it's water that's going to evaporate and go all the way through here, so we change the flask, don't keep the same flask. Anyways, we have the condenser. The condenser is where the heat exchange take place. That is, the gas will become colder or will cool down, and it will turn into liquid. Okay, and this liquid is gonna fall into the flask, or the Erlenmeyer flask. That's its full name. And this liquid, we call it the distillate. Okay, so what I want from you is that I want you to read page. So I want you to read. The homework would be, let me write it down in red. The homework, it would be reading page 32, and we are going to solve the analysis. And finally, copy the notes from video on the book, or on the notebook, I'm sorry, on the notebook. And I'm gonna write down the homework as well as an assignment. And if you have any questions, don't hesitate to ask. Have a good time and enjoy your time and be good, okay?